Okay, so the next two examples are actually examples from the beginning of the school year when we talked about modeling with linears and exponentials and comparing the two. So up first here we have Rohiza has an above ground pool that holds 20,000 gallons of water. She notices that the pool seems to be losing water continuously through a leak at a rate of 1% of the total volume of water every hour. Write an exponential function of the form f of x equals a times b to the x to model the scenario. Okay, so keeping this in mind, we talked about our initial. So with a word problem, your a value is going to be your initial value. Okay. We also talked about that with the word problem, you have to find your percent change. How is it changing? So to find your b, that's our percent change. Okay. So I'm sorry, our change that's taking place. It's not our B. We're going to use our percent change to find our B. Our B equals our, so 100, either plus or minus our percent change. Okay. So in this case, because it's a leak, our B is going to equal 100% minus 1%, which means B equals 99%. So our B value is going to be 0.99. Okay. So we have our A, we have our B. So can we write our function model? And the answer is yes. So we have f of x equals our initial, which is 20,000, times our B, which is 0.9 to the x. And that would be our function. Now that we have that function, we can then say, okay, well, if x is our time, and we can estimate in hours. So if x equals 4 hours, can you now calculate how much water is remaining in the pool after 4 hours, or how much water is remaining in the pool after 10 hours, or however long? Or you can try to find out how long is it going to take till the pool is empty. But we had to rewrite it and keep those in mind. So this is, again, review from previous year. Example 6 is also a review problem from the beginning of the year. I don't know if y'all remember when we talked about the Bronco SUVs and how the prices of the Bronco changed. So in order to do this, we have to find our change. So it says here in 2017, the average value of a vintage Bronco SUV in perfect condition was $47,200 compared to $23,400 5 years earlier. Write an exponential function to model the scenario, assuming the percent increases in a value of the vintage Bronco occurs continuously. Okay, this is important right here. This continuously is letting us know that we're looking at an exponential model. So we know that in 2017, the value was 47,025. Okay. And we know 5 years earlier, so therefore in 2012, the value was 23,400. Okay, so those are our two values. And now we got to find our A and our B. Okay, if we're going to let, our initial value be the 5 years earlier, that's our A, right? So our A equals 23,400, and that's because it's our initial. It's where it started at. Okay, the next thing we're going to find is how is it changing? How is the vehicle changing over time? In order to find that, that's where we have to find our ratio. So our ratio of change is going to take place. So that's our y2 divided by our y1. Remember doing that? So our ratio of change here is we have 47,025 divided by 23,400. All right, so this is our ratio. So we found our ratio. To find the ratio, I'm going to plug this in the calculator and I'm going to get an approximate value. So approximately, I need a calculator. I'm going to open my handy dandy Sylvie here. I'm going to type in 47,025 divided by 23,400. And we get that, I'm going to say 2.01. That's our ratio, okay? So our ratio is that. Now we got to find our growth factor. Our growth factor depends on how our time is changing from one year to the other. So when we're looking at growth factor, it's going to be your ratio to the power of 1 over your time. So what is your time? Okay, so that's our growth factor. And so for us, our growth factor, that means that that is your B value. So for this, our B equals, we found our ratio. Our ratio is 2.01. And this is our time over from here to here is 5 years, right? So it'll be 1/5. So our B equals 2.01 to the 1/5. All right, so we have our A, we now have our B, and now we can write our function. So we have f of x equals 23,400 times 2.01 to the x over 5, okay? So that's what our function is. So it says, can you use this information to determine the condition of the Bronco in 2021? Okay, so we're looking for when x equals, look for the condition of 2021. So 2021 minus our initial year, which was 2012. Sorry, 2012. And that's going to give us 9. So we're looking for when x equals 9, what is the value of the vehicle, right? So we're looking for f of 9. So we're going to go to the calculator. I'll go to my calculator and I'm going to type in 23,400 times 2 and 100 to the, and we have 9 divided by 5. That's not a 5. And we hit enter. And in 9 years, the approximate value, if what's happening is happening, of our Bronco would be 82,218 and 35 cents. And that would be the value. Okay. So major takeaways here is that when you have a gap in your time, so it's not a consecutive back-to-back counting, 1, 2, 3, 4, or 4, 5, 6, 7, you have to take that into account when you're determining your growth factor, okay? Your B value. Your B value is going to be your ratio to the power of 1 over the time or the changing your x, okay? How are your x's changing from one to the other? In this case, it was time, so I wrote 1 over t, but what you're really looking at is the change in your x. Okay, so let's try to make this into a rule we can follow, right? So to find our B, giving 2 points, B is going to equal y2 divided by y1 to the 1 divided by x2 minus x1. And that's how you're going to find your B value given 2 points. Your A value is going to be the initial. And then it all comes together. Okay. All right.